Maybe. Okay, so now we're going to talk about some other types of solutions. Everything we've done so far has had a unique solution. First, this topic talks about a 2x2 system. That means that it has two equations with two variables. And that's what we've been doing, right? We've had two equations and we've had x and y, okay? So we have three options for solutions, okay? The first is one solution, and that's what we've done so far, right? We solve it, we get an answer for x, an answer for y. The second thing that can happen is we can have no solution. We have no solution when the variables cancel and the remaining statement is false. Like 3 equals 5, right? That's not a true statement, right? So then we would know if that's what we ended up with, that it was no solution. We can also have infinitely many solutions. That happens when the variables cancel and the remaining statement is true, like 9 equals 9. But when we say infinitely many solutions, it doesn't mean that every single number will work for x and every single number will work for y, right? Because those two depend on each other. So in the situation where the variables cancel and the remaining statement is true, we solve an equation for y and say that it's infinitely many solutions of the type y equals whatever. Okay? So let's do it. So it says choose the best description of the solution. If applicable, give the solution. Okay, so notice we have no solution as a choice, we have a unique solution as a choice, and we have infinitely many, and then we tell them what it must satisfy. Okay, so the first thing I notice on this first guy is the bottom equation doesn't have the constant, right? The constant needs to move over. So let's go ahead and on that second equation, we're going to rewrite it with that 4 on the other side. So my top guy is still negative 4x plus y is negative 4. And the bottom guy is 4x minus y equals 4. So I think you can see that if I add these guys together, everything cancels out, right? And I end up with 0 equals 0. Is that a true statement? Yes, 0 equals 0. So that means that this is infinitely many solutions. Okay? But again, we can't put in a 42 for x and a million for y, right? Clearly that's not going to work. So what we do is we pick an equation, it doesn't matter which one, and we solve it for y. So I'm just going to take this guy, and I'm going to move the 4x to the other side. So I'm going to have y is 4x plus 4. So the system has infinitely many solutions, but they must satisfy the equation y equals 4x plus 4. Meaning x can be any number, and then what y is depends on what x is. Okay? Let's do another one. On this one, everything's in the right spot, right? And you see that I can get rid of the y's. So let's add these guys together. And we will have negative 6x equals negative 6, right? And then dividing both sides by negative 6, x is 1. So that means this one must have a unique solution, right? Because we're getting a solution. Because it's not 0, well, because our variables didn't go away, right? We still have an x there. When we still have variables, then we have a solution. If our variables go away, it's either no solution or infinitely many, depending on if the statement is true or false. Now that we know what x is, I will plug that in and get y. I'm just going to use the top equation. It doesn't matter which one. I'm going to have negative 3 times x, which is 1, plus y is negative 3. So I would add 3 to both sides, right? And y is 0. So that one has a unique solution, and it is 1, 0. Okay. Oh, let's look at the next one. Again, on that top one, I see that I need to move the 3 to the other side. So let's do that. My top guy becomes x minus 3y is 3. And my bottom guy is negative x plus 3y equals negative 3. So all the signs are different, right? So when I add these guys together, everything goes, right? The x's cancel, the 3y's cancel, and the 3's cancel. So 0 equals 0 is true, so infinitely many solutions.
How did that become a negative 3 at the bottom? The one you moved?
This guy, we moved him. Right, we moved him, so we subtracted 3 from both sides. Yeah. Okay? And so now what we need to do is solve one of the equations for y. Doesn't matter which one, I'll just pick the top one. So if I'm going to move the x, I would have negative 3y equals negative x plus 3. Dividing everything through by a negative 3, y is positive 1/3 x minus 1. So infinitely many solutions of the equation y equals 1/3 x minus 1. Last one. Let's go ahead and add them together and see what happens. X's cancel and the y's cancel, and I'm left with 0 equals 10. Is that true? No, no solution.